In this video, we're going to introduce division through applications and look at some language and notation we use for division. So let's read through our problem, highlight our givens and our goal. Adrian has just bought 12 lollipops for her 4 friends. So that's our given information. And now our goal is, how many lollipops will each friend receive if they are shared equally? And I'm going to count that. This is more as a given. So she has 12 lollipops for 4 friends. They need to share them equally. We want to know how many lollipops each friend will get. And again, you may already know the answer to this, but our goal is to try to visualize and get pictures and understanding of what division is with these simpler problems, so it'll make more sense when they get more complex. Okay, so let's try to imagine this. I'm going to draw lollipops. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are our 12 lollipops. Okay, and now she has 4 friends. So let's put the 4 friends down here. As you can see, this is why I didn't go to art school. Okay, so we want to take these 12 lollipops and share them equally among these 4 people. Or equivalently, we want to take the 12 lollipops and we want to partition them into 4 groups of equal size. And our goal is to find the size of the groups. Okay, so hopefully you're seeing the connections between this and the multiplication language. With multiplication, we said we had maybe 5 groups of size 4. Here we're saying we have some amount. We're making 4 groups. We want to know if the groups are the same size, how many are in each group. So here we officially, you may know because you can divide, but we officially don't know how many of these to give to each person. Okay, so we can think of them as dealing them out like a deck of cards. So here's what I'm going to do. So I'm going to use a different color to give everybody a lollipop. So now everyone has 1 lollipop. Okay. Now we're going to keep giving out the lollipops until we are completely out of lollipops. Okay. And now everybody has 2 lollipops. And notice in the end, we are out of lollipops. We've broken them into 4 groups, where each group is the friend. And the size of the groups are the number of lollipops each friend gets, which is 3. So we're going to write this using division notation. 12 divided by 4 equals 3. So if we have 12 lollipops and we share them equally among the 4 friends, we're breaking 12 into, partitioning it into 4 equal groups. Each group will have size 3 lollipops. Let's look at the next one. So Crystal has 12 bananas. She needs 4 bananas to make a banana cream pie. So that's our given information. I see the goal coming up with the question and the word how. How many pies can she make? Now again, you may already know the answer. She can make 3 pies. You may already be thinking 12 divided by 4, and how is this even different from the last one? But it actually is a little bit different in context. She has 12 bananas, and she's going to group them into 4s, and we want to know how many groups of 4 there are. Okay, so remember in the last one, we are breaking them into 4 groups and we needed to know the size of the groups. Here, we're grouping them into 4s because we know each banana pie takes 4 bananas, and we want to know how many groups of 4 or how many pies we can have. So it's important to see these two different contexts because they seem very similar, but sometimes when, it's 3 halves lollipops for 2/3 of our friends. I know that wouldn't happen because there aren't fractional friends, but it can be more complicated and it's harder to see the division. So this is another way of thinking of division. So let's make the bananas. So we have 12 bananas. That's 1, 2, 3, 4, 5, 6. Okay, they look more like moons. 7, 8, 9, 10, 11, 12. So now I'm thinking of the 12 bananas, and now I'm going to group them into groups of size 4 because we need 4 per pie. Okay, so this is going to be enough for 1 pie. That's enough for the 2nd pie. And this is for the 3rd pie. So she can make 3 pies. So again, 12 divided by 4 gives us 3. Okay. Also, another way to think of this that connects to multiplication is, remember with multiplication, we could think of it as repeated addition. Well, similarly, we could think of this that we just did as repeated subtraction. So we started with 12 bananas. We take away 4 for the first pie, and we get 8. Then we had these 8 left. We take away 4 bananas for the second pie, and now we have 4 bananas left. Then we use the last 4 bananas for the 3rd pie, and we have 0 bananas left. So we subtracted 4 3 times till we got to 0. So repeated subtraction for addition, repeated subtraction for division is basically saying, start with your first number, the amount you have, subtract off as many of these quantities as you can until you get to 0. So now that we have these ideas in general, let's take a look at some of our notation. Let's highlight this. We call the number we are dividing the dividend, the number we are dividing by the divisor, and the result is the quotient. Okay, so notice, unlike multiplication we had the 2 numbers we were multiplying were just called factors. The answer was the product. Here, these have different names because they play different parts in the problem. So dividing 12 by 4 is not the same as dividing 4 by 12. So let's think of, that's a highlighter. Let's think of just something simple with a pizza. If you had two pizzas and you shared it with 4 people, now this would give us a fraction, but I think you can imagine that you would each have, there's the 2 pizzas, break it into 4 pieces, you would each have half a pizza. That wouldn't be nearly as good as if you had 4 pizzas and shared it with 2 people. You each would get 2 pizzas. So notice switching these numbers makes a difference. The dividend and divisor cannot be interchanged. So the first one is a dividend, second one is divisor, and we call the answer the quotient. Here are some words that we may say to read something like this. 12 divided by 4. We may say 4 into 12 or 4 goes into 12. So notice when we rewrite it this way, the 4 comes first in the phrase, although in the symbolic representation it's in the other direction. And since the direction matters, you have to be careful that you know when you say division this way, 4 into 12 means 12 divided by 4, not 4 divided by 12. We might say 12 over 4 when we write in fraction form. Okay, and we're just going to look at fractions as division now. You'll learn more about fractions later and other ways to think of it. Or we may say the quotient of, which is the answer of 12 and 4, where the first number is the dividend, the second number is the divisor. These were the two ways that we looked at this in our example problems. We said how many groups of size 4 are in 12, so this was like the banana problem. How many groups of size 4 bananas are in 12 bananas? And this one is a little bit harder to say, but it's still good to know this idea, is if 12 is broken into 4 equal groups, what is the size of each group? And that was like the lollipop problem. Okay, we had the 12 lollipops. We broke it into 4 equal groups of lollipops per friend, and our goal was to find how many lollipops each friend had or the size of the groups. Now here's some other notation. We have this division symbol. Okay, 12 divided by 4. We could put one or both of the numbers in parentheses, and again typically we do this when we have negative numbers. And then here's the fraction form, 12 over 4. So this is equivalent, and we one way to think of fractions is division, so we want to start getting comfortable with this. Something nice to notice is that notice the division symbol. It's actually derived from this fraction form, or these two are connected. I'm not sure which came first. But notice you could think of that little bar in the middle of the division symbol as like the fraction bar. And then we have the 2 dots where here, that's where our numbers go. So that can help you connect the idea that these are both division.